Hey guys, welcome to another episode of TinkMakes. Today it's just gonna be me, so I guess you guessed it. We're gonna be designing something simple and easy to print. I'm sure you have heard me and Eugene talk about our new boom mic setup. We used to use lavs, but then now we're going to be using boom mic. I've shown our boom mic here a bit so you guys can see. And what we have was a boom mic with a mount that mounts to the camera, but not to one of these poles that we have. So we need to create and design an adapter that will allow it to do that. And before that, I'll show you how sketchy we are holding it on right now. We're just holding it with tape. And it doesn't look very professional. So what else can we do? We can 3D design an adapter, and which is what I'm gonna do in the next couple minutes. I'll take some measurements, show you what our boom mic looks like right now, and then I'll start CADing. So this is what a boom mic looks like right now. It's held on by tape, so it's actually pretty sketchy, right? We don't have an adapter for it, and I don't know if there's any adapter right outside, but the best thing about 3D printers is I can just design something, right? So I'm gonna design this adapter and then put this mount that is made for this boom mic onto the adapter, and then we're gonna put it onto this pole so it actually doesn't look as unprofessional as it looks right now. It's gonna be a lot sturdier and aesthetically more pleasing. So before that, I'm gonna have to take some calculations before we jump right into designing in Onshape. Yeah, so I'm going to start my design right now. And I was just looking around the warehouse on the lights that we have, if I can take some examples out of it. And I can actually, we look here, this adapter is exactly what we need with a few alterations. So I can just measure this part and just take this adapter here and then make it a custom made one, and we can use that to outfit our boom mic. So I'll just take some measurements here now and also draw out my design, which is roughly going to be the same look and feel as this one right here. Okay, so after finished taking all my measurements and everything, I believe I have the initial design. The boom mic is down here right now, so that's probably why you hear different sound quality, but this is what it will look like. Right here, it's like the same adapter is here, but I added a piece which you can slot the boom mic adapter in, and that's going to be the main difference. And yeah, let's start CADing. Okay guys, so I have my design and everything. I just showed it to you earlier, and now I'm in front of Onshape once again. Before I CAD it up, I'm gonna ask Eugene for some fellow designer advice to make sure that my design is appropriate, which I think it is. Hey Eugene, you wanna come over and just check my design very quickly?
Sure.
So my design's right here. I basically stole the design from one of our lights from our set. I thought the same adapter can work with our boom mic adapter, so I just took the general design and just did some measurements and added the slot where you can put the boom mic in.
The boom mic mount itself.
Yeah.
Okay, well, it's kind of like reverse engineering.
Yeah.
So, I mean, it works. Yeah, give me this.
Yeah.
Okay. How are you gonna print this?
I was thinking like this. So the tube is actually facing up, and then put support underneath where the slot is for the boom mic.
I mean, that could probably work. There's probably a way better way to orient this object. You have to change a couple things though.
Yeah.
You have a pen?
Yeah, pen right here.
Okay. So I'm not gonna draw on this because I don't want to mess that up.
Yeah.
let's assume for a second that we follow that exact same profile on the top.
Yeah.
And like the problem is, even if you print it this way, like you have to get rid of all this, right?
Yeah.
You got to peel it away, and that thing isn't going to slot in as nice.
Yeah.
So why not print it in this exact orientation up? So
it eliminates the
you don't need any support.
overhang.
Yeah, no overhang. So you come down. I just go like you've got this portion here, right?
Yeah.
And you got your two whatever.
Yeah.
So make your profile follow like that shape.
Yeah.
Something like that. And obviously you still have a bottomed out thing here, right? So that's still down there. Then this inner tube, this diameter here will be the basis of that.
Yeah.
But then what you can probably do in turn is, just for better printability, like do a teardrop. Right, so now your so this is your bottom.
Yeah.
So your object is going this way.
Yeah.
And then you can add a little chamfer down here. Like you can cut time by adding chamfers if you want to, right? And then your set screw goes like somewhere there.
Yeah.
Comes in. So like this equals 1724.
Yeah.
The circle.
Yeah.
And then I guess the height will be at least 24.8.
Yeah.
Right?
Yeah.
And then you can just print it in that orientation. Everything being the same. Oh, sweaty.
Okay, so
it just makes it for like you don't have to do post-processing. You don't have to worry about if this slot gets filled with support structures.
Yeah.
You just don't even have to worry about that. And then everything else stays the same.
Okay.
Orientation matters significantly.
Yeah.
Yeah. It like if you look at it, it's actually the same. It's just we extended this out.
Yeah.
And then we changed that to a teardrop.
Yeah. And that eliminates a lot of things.
Yeah. It'll probably take a little longer to print.
Yeah.
But it'll be an easier print to deal with.
Okay.
Yeah.
Awesome. Okay, so just some tips from Eugene was like there's nothing wrong with my design in the first place. It's just some tips from him is for 3D printing, you might want to design with the orientation in mind. So be a bit more, I guess, adapt a bit more for the 3D printing technology. So we are changing a couple things to my design, which instead of a circle, the top of a circle is very hard to print because it is a very high angle, and very high chances is that it's going to be drooping at the top. So an easier thing that Eugene suggested was build a teardrop. So at the top of the circle, it has a slightly lower angle where it can still build on top of each other. Or did I say that backwards? Yeah. So essentially, essentially the teardrop is supposed to allow it to have less of that angle so that it can print on top of each layer. Maybe I guess sometimes later on when I design it, you'll understand why Eugene suggested that. And yeah, the orientation, instead of printing support now, the new orientation that Eugene mentioned to me will actually eliminate the support materials that I need. And we can just print it face flat instead of the side profile, not the side profile, but the tube going up. Yeah, so I guess without further ado, I will get into CADing. Hopefully from this CADing experience to the last one, that I'm a bit more back into the groove, and I can actually whip this up a lot faster than before. So back in Onshape, I'm gonna create a new document called Boom Mic Adapter. Okay, so I can't figure out how to move it down a bit more. So I want to extrude to the other side as well. I want to be deeper, so and then now I need a new sketch, which is on top here. What I need now is, I guess, a rectangle. Okay, so the thing is, how do I move this? Front. No way for me to do that. I just gotta figure this out and then cut and I'll be done. And so I guess in this way, Tinkercad is actually a bit easier to move your shapes around. Well, right now I'm a bit stuck on how to move this to the front. Okay, so I'm guessing calculator 19.4 minus 1.48 is 17.92. 17.92 here should get. Okay, so we're back. While the battery was charging, because I just ran out of battery earlier, I was trying to figure out how to move that part, as everyone saw, up to where it needs to be. And that was a very frustrating process because I couldn't, for the life of me, to figure out how to move it up. I've been so, I guess, anchored to how Tinkercad works. I thought it would be so much similar to it.
But while the battery was charging, I actually went and asked Eugene, how do we actually do that? And what he taught me was actually life-changing for CAD. And well, for using these more advanced CAD programs, it's like the thinking pattern that you have to do is completely different than Tinkercad. He was telling me there was all these ways to do it, while Tinkercad lets you do the same thing, but that kind of limits you to just 2 ways of doing it, while these advanced CAD softwares have like at least 3 to 5 ways to do the same thing over and over again. So from this experience over the past hour, you guys watched me struggle, and CAD is it's pretty hard. Well, to enter into CAD with not knowing anything is pretty hard. But what Eugene taught me was, for the tips, was you can actually select, after you extrude, you drew your initial object, you can actually select the face on the object that you want to work on the side of the object that you want to work on. So that changes everything. I don't have to be stuck and anchored to one plane and work around that. And what I did wasn't wrong, but it was a very roundabout way of getting there. So there's a lot more easier ways to actually achieve the same results that probably could have actually reduced my time from 50 minutes to probably like 20, 30 minutes in creating this piece. So I'm not gonna let my work go to waste. I'm just gonna probably redo that one part that you all saw me struggle with, and then afterwards we can print that part out after I'm done. So let's get back in. That's the center of the point, and then this. I need it to be 2.5 millimeters. And then, now that I have that, actually, for this part, I don't know what would be an easier way. Would it be, so give me a quick second. I'm gonna ask Eugene behind me. Hey Eugene, making the set screw hole, is it faster to use the extrude cut function, or is it faster to use the hole function? Or is there even a difference?
They're very close, but the extrude cut function probably for your purpose will be easier.
Okay.
More so for dimensional drawing. Because it'll actually pull out the.
Yeah, yeah.
For us, because we know what the diameter is, just put a hole, dimension it to whatever size, it's 2.5.
Yeah, yeah. Okay. I'm sure I measured everything correctly, and this part should work. So right now we will print it out. So low doesn't need to be dense because it doesn't have to be like our last part, which is holding up a whole
glass door. So I'm gonna make it low, sparse. 2 walls is fine. Speed, I'm gonna speed it up again. And then slice. This part takes 44 minutes to print. As you can see, seems like a relatively easy print to do now. Yep, so now I'll just save it and then I'll start it on the printer right behind me. Okay guys, so I finished printing this print. It took roughly around 40 minutes to print. And we can test it right now, so the moment of truth. So this fits in no problem. So I'll have to set screw it later. But let's check if this, the main thing is whether or not this slots in here. So it's actually a bit tight and I can't push the whole pin down. It'll work this way, but I want it to be perfect. So I guess I have to go back to Onshape and readjust this. I wonder if I did the same mistakes as when I was building the scooter, where I thought I'd added 3 for the tolerances, but it's in reality I only added 1.5 on each side. So in order to add 3, I actually need to add 6 in the total. Yeah, so I'll have to adjust this because it's not going in. Okay guys, this is the new part that came out. I made the adjustments, made this slot wider so that I can slot it in, and then yeah, that's everything that I did for the new part. So now we're gonna put it in and test this out. So right here. Oh, yeah, it slides through right now. I think I fixed my earlier problem with not... but essentially, I made the same mistake as I was doing the scooter. Thought I added 0.3 on all sides, but I actually added 0.15 on each side. So next time in the future, when I do make these things, I should remember to actually put 0.6 instead of 0.3. Because with 0.6, then I actually add 0.3 on both sides. So now I've tightened this, and now I'm gonna put this on, slides on just like that. And then the set screw hole at the back should allow me to tighten this. So it's tight now, as you see. That should be good. Yeah, so quick, simple part that could have been done in 15 minutes, but due to my inexperience with CAD and just being so anchored onto Tinkercad, the ways of making this took longer than expected. It took me 50 minutes, and then after the tips that Eugene gave me, I think created this a lot faster. And then apart from the first prototype failure, not much was done to actually make it into a second part, because this was actually something that I ran into last time making the scooter as well, just didn't take account the tolerances. So this is everything for this episode, but some thoughts is just CAD does have a very steep learning curve, as you guys saw earlier. I did struggle quite a bit not knowing that Onshape actually works differently than Tinkercad. I keep thinking I can just drag the thing up, but didn't know that you can actually create and make stuff on the selected face after you extrude, so you have your actual whole object. And that actually changed, well, wouldn't be exaggerating if I say it actually changed my CAD career or life. So yeah, a lot of things to learn about new CAD programs, but I'll guess I will see you guys in the next episode when you see me design other things to help with the set or just around the company itself. But before that, remember to subscribe and comment on below. Click the bell for the next episode and also leave us a comment. I'll see you next time. Bye.